implicit differentiation. So it's a little review of how to do implicit differentiation. So consider the curve this, so they give something with x's and y's. They generally want you to take the derivative. They most likely would have you say it. They'll say something like find dy dx. So don't forget when you're taking a derivative of this guy, there's a lot of product rules. So like here, you take the derivative of dx, it's a product rule. So that'll be the derivative of the first one, 1, times the second one left alone. Plus the derivative of the second one, just take the derivative normally, 2y, but then it's the wrong variable, so you have to put dy dx. Times the second one left alone, which is x in this case. Right, then you subtract, or you get there, and you do the exact same thing here. Right, that's implicit differentiation. Then we're going to move it all on one side. Let me just real quick actually. So I'm going to treat these together. So the derivative of the first one would be negative 3x squared times the second one left alone, plus the derivative of the second one, which is 1, but wrong variable, so dy dx, times the first one left alone. And then all equals to, don't forget the derivative of 6. You gotta take the derivative of 6. In this case, it's 0. So you get all that. So let me rewrite it a little nicer. X squared y plus dy dx times negative x cubed equals 0. So what we do next is you want to get dy dx's all on the same side. So right now they already are, but I can move everything else out of the way. So I'm going to subtract the y squared. I'm add over to 3x squared plus y. So you can get this. Minus x cubed dy dx equals 3x squared y minus y squared. So you get all that. Dy's on the same side. Now you could factor them out. So they both have it. So you factor it out. Dy dx 2xy minus x cubed equals 3x squared y minus y squared. Divide by this, and you get your implicit differentiation, your solved derivative. So that's how you do implicit differentiation. Now sometimes they add in an extra part, like they'll say find at 1, 2. All that means is plug in 1, 2. 1 for x, 2 for y. So in this case it'll be 3, 1 squared times 2 minus 2 squared over 2, 1 times 2 minus 1 squared, or cubed, or whatever it was, cubed. Right, that's all it is. Simplify, get your answer. And if it's free response, leave it like that. But that's all implicit differentiation is, right? It's take a derivative, don't forget product and quotient rules are in play, and then move everything over, get them on one side, factor out, and then divide. So let's do a couple quick examples. Consider the curve given by this. Show that dy dx equals that. So starting off, they want you to take the implicit differentiation. So take the derivative of that side, so that's 2y, wrong variable, dy dx. And then derivative 2 goes away. Derivative of this is a product rule. Derivative of the first is 1, derivative of the second, derivative of the first times derivative of the first one times the second left alone, plus derivative of the second one, y is 1, but wrong variable, times the first one left alone. Right, so next step is you want to put the dy's on the same side. I'm going to subtract this over because there's only one of them. So I'm going to get 2y dy dx minus x dy dx equals y. Factor out the dy dx. Divide by it. So dy dx equals y 2y minus x. Just like they got. Final points on the curve where the tangent line to the curve has a slope of 1/2. So tangent line to the curve, that's the derivative. That's dy dx. So set your thing you just found to dy dx. To 1/2, sorry. So we're going to set y 2y minus x equal to 1/2. If you cross multiply, you're going to get 2y minus x equals 2y. 2y's cancel. Negative x equals 1. X equals negative 1. So that's B. C. Show there's no points on xy curve which the line's tangent to the curve is horizontal. So we're saying show that the derivative doesn't equal 0. That's what they're saying. So very similar. Y over 2y minus x equals 0. If you cross multiply, you get y equals 0. Now again, they want to say that so it doesn't work. So something should be wrong here. Let's go back to our original equation. Y squared plus 2 plus xy. So our original equation is this. Equals, oh, y squared, I wrote down the wrong equation. y squared equals 2 plus xy. If I plug that in, does it hold? I get 0 equals 2 plus 0. So no. So something's wrong. This does not happen. Not possible. Okay, one more. So similar idea. First, show the derivative equals that. So let's do no implicit differentiation. Right, take derivative of that one, 2x. Derivative of that is 8y, but wrong variable, so dy dx. Equals, derivative of 7's gone. Derivative of that is a product rule. I actually keep these two together. So derivative of the first is 3 times the second left alone, plus derivative of the second, which is 1, but wrong variable, dy dx, times that left alone. Right, so now try to get the dy dx on the same side. Let's move stuff over. Let's see. I'm gonna move this over there because they have a positive 8y, so I'm gonna keep that positive. Move that over there, move that over there. So 8y dy dx minus 3x dy dx equals 3y minus 2x. Factor out the dy. Divide by 8y minus 3x. And you should get the same thing they got. There you go. Second, show that there's a point P with the x-coordinate 3 at which the line tangent to the curve P is horizontal. Find the y-value coordinate. So again, another way of saying this is just saying horizontal tangent line, it's just saying the derivative equals 0. So they're saying this guy equals 0. But they're telling you, hey, the x equals 3 though. So we're going to set this equal to 0 and plug in x equals 3. So 3y minus 2x over 8y minus 3x equals 0. But again, we're plugging in 3 here. So I'm going to get 3y minus 6 over 8y minus 9 equals 0. Little cross multiplication. That goes away. You just get 0 equals 3y minus 6. Add 6 divided by 3. You get 3y equals 6. Y equals 2. So that's B. And then C. Find the value of the second derivative at point P, found in part B. Does the curve have a local max or local min, or neither as point? Just for your answer. So remember our point we just found. Our point is 3 and we found, was it 2 for y? So that's our point. That's P. So we're going to plug that in. So this basically wants to find the second derivative. Plug that in. If you get a positive, it's concave up, so it's an underestimate. I guess not underestimate, local min. If you get a negative, it's concave down, so local max. So let's take the second derivative. So C, let me rewrite it so we can see a little nicer. That's our first derivative. I take a derivative one more time. So now this one's gonna be a quotient rule, because you know AP calculus is lovely. So let's do it. The derivative, that's a second derivative. So quotient rule, derivative at the top. So that's gonna be 3, wrong variable 3, but the wrong variable, so dy dx. Minus derivative of that. Well, derivative top is just that, minus 2. Times the bottom left alone. Minus derivative of the bottom. So that's going to be 8, wrong variable, dy dx. Minus 3 times the top left alone. All over the bottom squared. Right? So that's our second derivative. Just getting that's fine. And technically you want to plug these guys in for dy dx. But I'm going to leave it like that for now. Now it's going to be not as bad as it seems. Next they want us to plug in the point we just found, which was 3, 2, because they told us x was 3 and we found y was 2. Right there. So I want us to plug that in. So when you plug it into here, you get 0, because that's the whole point of this right here. So when you plug in 3, 2, you're supposed to get 0. So I'm going to get 3, 0, because remember the whole point when you plug that needs to get 0. Minus 2, and then 8 times 2 minus 3 times 3 minus 8 times 0 minus 3, 3 times 2 minus 2 times 3, all over 8 times 2 minus 3 times 2 times 3. No, minus 3 times 3 squared. So this is going to be negative 2. That's going to be 16 minus 20, not minus 9. I can do math. That's going to be 0. It's going to be negative 3. That's going to be 6 minus 6. So 0. So I get negative 14 over 16 minus 9. So 7 squared. So I get negative 14 over 49. That's negative. That's all I care about. So it means it's opening down. So we have a max. Whew. That is it.